Hello, today we're going to talk about reactivity 2.1.4 and 2.1.5. This is all about percent yield and atom economy. So let's take a second to review limiting and excess reactants. Limiting reactant gets used up. And so because it gets used up, it determines your theoretical yield. The excess reaction, you have extra of it. So you'll have plenty for the reaction and you'll have some left over. We can't use that amount to determine anything because not all of it's going to react. So we're going to focus on the limiting reactant and use stoichiometry to figure out the theoretical yield. Once you have the theoretical yield, you can use that to calculate the percent yield for a given reaction that's happening in the lab. And so your equation is actual yield, what you make in the lab, over your theoretical yield, what you calculate would happen in a perfect world using stoichiometry, times 100 will give us our percentage yield. So how much you really made over how much you were supposed to make times 100. And depending on the situation, you'll have very widely different percent yields. Some reactants go very close to completion, like get really, really high percent yields. Some reactions are considered very successful at like a 50% yield. So it just depends on the particular reaction. Now notice that this is different from percent error. Percent error is actual minus theoretical. Absolute value there, all over theoretical, times 100. So this is percent error. This is how far off you are from your goal of the theoretical yield. So just be careful with the two there. Now another way that we can measure the success of a reaction, like how good it went, is something called atom economy. And this formula is in your data booklet. But the percentage atom economy is equal to the molar mass of your desired product, what you're trying to make, divided by the molar mass of all reactants added together, times 100. So you do not include any side products, basically. And so this is a principle of what we call green chemistry, where you're trying not to make too many waste products. Producing less things that are undesirable is considered a green principle. And so atom economy tells us how close we are getting to like fully using up all of the reactants to make desired products. And so, yeah, just remember that that's in your data booklet, near the front of the data booklet in your equations, and be able to, say why that could be a useful measure for green chemistry. So let's look at a couple examples here. We have pentyl ethanoate, which smells like bananas, which is a fun fact. Esterification is a cool reaction if you get a chance to try it. But it's produced from the esterification of the carboxylic acid and the alcohol to form the ester and water. Now, reaction uses 3.58 grams of the acid and 4.75 grams of the alcohol and has a yield of 45% to determine the mass of ester that forms. The first thing you need to do is calculate your theoretical yield. So I'm going to test both of my reactants because I don't know which one of those is the limiting. I'm going to change grams to moles using their molar mass. The acid's mass is 60 grams per mole, and the alcohol's mass is 88 grams per mole. Now I can use my mole ratio. Fortunately, it's all 1 to 1 to 1. So I'm going to just abbreviate. This is the ester for every acid And it's a 1-to-1. There's one ester for every one of the alcohol. And then I can go back to grams because our question is asking for mass, and put in the molar mass of the ester. And its molar mass is 130. And go ahead and let's calculate what could be made in both scenarios. The first one could make 7.76 grams of the ester. This one can make 7.02 grams of the ester. So this one is our theoretical yield. Abbreviate theoretical yield. This thing is our limiting reactant. The acid must be our excess reactant. This much could not be made because you'd run out of the alcohol before you were able to make enough to use up all of the acid. So that's your theoretical yield. Now it says it has a yield of 45%. So you can't actually make 7.02 grams. You can only make, if I multiply by 0.45, you can only make 3.16 grams of the ester at that 45% yield. So this is the mass of ester that you can really make, that you can actually make in the lab. This is your actual yield. This is your percentage yield. Our second example here has to do with nickel. Nickel can be produced by heating nickel oxide and carbon in the following reaction. Calculate the atom economy for the production of nickel. So that means nickel is our desired product. Its molar mass is 58.7. And then the total for all of the reactants on the product on the bottom there. So 74.7 for the NiO and 12 for the carbon, and then times 100. We get an atom economy of 67.7%. So that means 67% of the mass is what we want as the products, and the other percentage is waste product. The carbon monoxide gas is the waste or the byproduct. So both of those things, atom economy and percentage yield, both give important information about the efficiency of a chemical process. What other factors should be considered? So you can always consider things like safety, how safe it is to use particular reactants or products or processes. Some reactions have very involved mechanisms. Another thing that you can consider is the price. Like how much it costs to use particular reactants versus other reactants. Local regulations is another one. Are you allowed to use a particular process and other particular reactants? The ease of disposal for any byproducts is also another one. Not just how much is disposed, but how easy it is to dispose of it, how safe it is to dispose of it. Lots of considerations when you're deciding on a method to synthesize a particular product that you're looking for.